Hello everyone, my name is Vimlesh Sahu, guest lecturer, Department of Computer Science, Pandit Sundarlal Sharma Open University, Koni, Bilaspur, Chhattisgarh. Today we are going to study something extremely important, the foundation of the modern internet, the TCPIP reference model. Before we start, I want you to think about this. How many times today have you checked your WhatsApp, watched YouTube videos, sent an email, used Google, made an online payment? All of these activities depends on the powerful communication system TCP/IP. By the end of this lecture, you will clearly understand why TCP/IP was created, how its four layers works, how data travels across the world in seconds, and now everything connects together. Let's begin our journey into the backbone of the internet. Before understanding TCP/IP, we must understand why networking exists. Imagine a world where computer cannot connect. There is no internet, no online banking, no cloud storage, no online classes. Networking allows computer to share data, resources, services, applications. When you attend online classes, your devices sends and receives data in real time. When you store files on Google Drive, your data travel across networks to remote servers. When you do digital banking, encrypted data moves securely between you and the bank server. All of this is possible because of networking. Networking is the backbone of digital society. Next, now let's understand protocols. A protocol is simply a set of rules for communication. Just like traffic follows signals, human follows grammar rules, exam follows instructions, similarly computer follows protocols. If two computers do not follow the same protocol, communication will be failed. The most important protocol suite is TCP/IP. It is not a single protocol, it is a collection of multiple protocols working together. Think of TCP/IP as the universal language of the internet. Without TCP/IP, Windows computer could not talk to a Linux server, a mobile phone could not access a website, a laptop could not send an email to another country. Let's look at history. In 1970s, researchers wanted to connect multiple computer networks. The scientists played a major role. Vint, Cerf, and Robert Icahn. They were working on ARPANET. The goal was revolutionary, connect different types of networks. Ensure communication even if part of the network fails. So, why was this important? Because military communication needed to survive even during failures. In January 1, 1983, ARPANET officially adopted TCPIP. That day is considered the birth of the modern internet. Today, billions of devices use the same system they designed. So, let's talk about TCPIP reference model. The TCPIP reference model is a four-layer model. These layers are application layer, transport layer, internet layer, network access layer. Each layer has a specific responsibilities. Think of it like a postal system. You write a letter, application. Post office ensures delivery, that is transport. Address determines route, that is internet. Physical route, transport, network access. This layered structure makes networking organized and efficient. The first one is the application layer. This is the topmost layer. It interacts directly with users. Whenever you open a web browser, send email, upload files, use social media, you are using the application layer. Unlike the OSI model, TCP/IP combines application, presentation, session layer into one layer. This simplifies the model. This layer prepares data before sending it down to lower. Let's discuss key protocols. HTTP, Hypertext Transmission Protocol. It is used for web browsing or browsing a website. HTTPS, secure version of HTTP used in banking and e-commerce. FTP, File Transfer Protocol. File Transfer Protocol is used for uploading a file or downloading a file. SMTP used for sending emails, where POP3, POP3 and IMAP handle receiving them. DNS converts domain name into IP address. For example, when you type google.com, DNS converts name it to IP. HTTP sends request. Server responds with web page. All this happens within milliseconds. Next, application layer in action. Let's look at this DFD. When you type google.com into your browser, the entire process takes place at the application layer before any data move further. The transport layer ensures end-to-end communication. Its responsibilities: reliability, flow control, error detection, segmentation. It breaks large data into smaller segments. But why? Because smaller packets travel more efficiently. Two more important protocol operates here. The first one is TCP and the second one is UDP. TCP stands for Transmission Control Protocol. It is connection oriented, reliable, ordered. Before sending data, TCP performs a three-way handshake. It ensures data is delivered, no data is lost, correct order maintained, and used in banking, email, file download. If packet is lost, TCP resends it. That's why downloading file is accurate. While UDP stands for User Data Game Protocol, it is fast, connectionless, no guarantee of delivery, used in online gaming, video streaming, voice calls. Here, speed matters more than perfection. If one packet is lost in video streaming, you may not even notice. Some important port numbers are used in transport layer, like HTTP. It is used port number 80. The port number 443 is used by HTTPS. Port number 21 is used by FTP, and port number 25 is reserved by SFTP. These ports range from 0 to 65,535. Well-known ports are 0 to 1023. So, the third layer is internet layer. This layer handles logical addressing and routing. Main protocol IP, Internet Protocol. The function is assigning IP address, route packets, fragment packets. Router operates at this layer. IPv versions and supporting protocols. IPv4 having 32-bit limited addresses, example 192.168.1.1, while IPv6 has 128-bit huge address space designed for future growth. IPv6 was introduced because IPv4 addresses were running out. Today, IoT devices require billions of new addresses. ICMP. These are the other internet layer protocols. ICMP used for error reporting and ping command, while ARP converts IP address to MAC address. Without ARP, local delivery would not work. How routing works. So here it is step-by-step procedure. First, source device. Device attaches destination IP. Router checks routing table. Packet moves hop by hop. Reach destination. Each router makes intelligent decisions. And the fourth layer is network access layer. This is the lowest layer. It handles physical transmission. Technologies Ethernet, Wi-Fi, fiber optic. It converts digital data into signal. Every device has a MAC address. It is a 48-bit hardware-based unique address. Example 00:1A colon 2B colon 3C colon 4D colon 5B. MAC address works inside LAN. IP gets packet to network. MAC gets packet to exact device. This layer performs framing, error detection, signal conversion, MAC addressing. Without this layer, data cannot physically travel. As data moves on, data encapsulation and decapsulation. Application layer creates the original data. Transport layer adds TCP UDP header including port number and sequence information, and then creating segment. Internet layer adds an IP header with source and destination IP addresses, creating a packet. And then network access layer adds frame header and a trailer for error detection, creating a frame ready for physical transmission. TCPIP versus OSI model. TCPIP, 4 layers. It is a practical layer of model, real world implementation, OSI layer, 7 layers. It is a theoretical model used for educational model. TCP/IP powers the internet. Advantages: and disadvantages of TCP/IP. Advantages: it is open standard, scalable, reliable, platform independent, supports routing. Disadvantages: no strict layer separation, no session layer, complex troubleshooting, security added later. Now the real life example is like opening a YouTube. Let's connect everything. When you open YouTube, DNS converts domain name, then TCP handshake establish connection. Step 3, HTTP request send. Step 4, IP routes packets. Step 5, Ethernet Wi-Fi transmits signal. Step 6, video loads on screen. All four layers works together simultaneously. TCP/IP is the backbone of global communication. Four layers: application, transport, internet, network, etc. working together in harmony. Without TCP/IP, no internet, no website, no online services. It is truly the foundation of the digital world. Thank you.